Bismillahirrahmanirrahim. Assalamualaikum viewers. My name is Ali Benison and I am a foundation level student at Real School of Bookkeeping Campus. To- Today I am going to talk with Maya on the topic, the history of our home in Abundant. So let's start. Hi, can you hear me?
Hi.
My first question is, what is Earth?
That's a good one to start with. Earth is the third planet from the sun, orbiting within what's called the habitable zone, that sweet spot where temperatures allow for liquid water. It's part of the Milky Way galaxy, and more specifically, we're in a spiral arm called the Orion arm. So basically, we're on a little blue marble circling a star within a massive island universe filled with billions of stars and planets. Does that help give you a sense of its place?
Okay, my next question is why is Earth called our home?
Sorry, I didn't quite catch that clearly. Could you say that last part again?
My question is why is Earth called our home?
Ah, got it. You're asking why Earth feels like home to us. That's a really deep question, honestly. I think it's a bunch of things. It's the only planet we've known. So there's this deeply ingrained connection through evolution and millions of years of adaptation. Our bodies are built for Earth's gravity, atmosphere, and temperature. But I think it's also more than just biological. There's this emotional pull, this sense of belonging, because it's where our families are, where our memories are made. It's where we learn who we are and where we feel safe, even though it can be chaotic too. What makes Earth feel like home to you personally?
Okay, my next question is how old is Earth?
Hi there. Nice to meet you. So, Earth is estimated to be around 4.54 billion years old, give or take 50 million years. Scientists figured this out by dating radioactive materials in meteorites and matching that to Earth rocks, as well as through analysis of lunar samples. Crazy to think about how long that is, huh? Pretty mind bending when you compare it to a human lifetime.
Okay, my next question is how was Earth formed?
I'm listening. Sorry, can you repeat the second part of that question? I'm not quite sure what you meant by from.
How was Earth formed?
Oh, you mean how was Earth formed, right? Basically, everything started with a huge cloud of gas and dust left over from when the sun was born. Gravity pulled everything together, and as it spun, it collided with tons of other space rocks. Over millions of years, it became bigger and hotter, eventually cooling down enough to form a solid surface. The early Earth was covered in volcanoes and had a really rough atmosphere. Then, over billions of years, things like volcanoes and space rocks brought the water here, and well, here we are. Does that make sense?
Okay, my next question is what does
Go ahead.
the word Earth mean?
That's a good question. The word earth comes from Old English and Germanic words meaning ground, soil, in Old English. It basically comes down to the idea of the ground we stand on, the stuff under our feet. It's pretty literal, actually. I always find it interesting how these fundamental words for such basic concepts are so old and widespread across languages.
Okay, my next question is why is
I'm listening.
Earth unique in the solar system?
Okay. So, Earth stands out for a few key reasons. First, it's the only place we know of with liquid water on its surface and in large amounts. That's pretty crucial for life as we know it. Second, its atmosphere is just right, not too thick, not too thin. It protects us from radiation while keeping the temperature stable. Plus, Earth has this thing called plate tectonics, where the crust is broken up into shifting pieces, which recycles nutrients and helps regulate the climate. No other planet in our solar system has that. It's a really special combination of factors that all seem to work together.
Okay, my next question is what makes Earth habitable?
Good question. It all comes down to some pretty specific conditions lining up just right. The distance from the sun obviously plays a role. Not too hot, not too cold. Then there's the atmosphere, which shields us from radiation and helps trap heat. Liquid water is huge, of course. And our planet's magnetic field protects us from harmful solar winds. Beyond that, having a stable star system and the right sized planet with enough gravity to hold on to that atmosphere are both critical. Earth just happens to hit all these requirements in a way that allows life to thrive. It's a complex system, and any one factor being off would change things dramatically.
Okay, my next question is how big is Earth?
Earth's pretty massive. It, it has a diameter of about 7,917.5 miles. That's how wide it is, if you could somehow cut straight through the middle. The circumference, going all the way around, is roughly 24,901 miles. And it's not perfectly round either. It's slightly flattened at the poles, making it more of an oblate spheroid. You'd need to drive around it almost 30,000 times to hit every single mile of Earth's coastline.
Okay, my next question is how what is Earth made of?
So, Earth is basically layers. At the very center is the inner core, which is solid iron and nickel, really hot and under intense pressure. Surrounding that is the liquid outer core, also iron and nickel. And that's what creates Earth's magnetic field. Above that, you've got the mantle, which is mostly rock and accounts for about 84% of Earth's volume. Finally, there's the crust, which is the outermost layer. That's where we live, and it's made of solid rock too, but it's much thinner than the mantle. There's also the atmosphere, which is mostly nitrogen and oxygen. Pretty wild to think we're standing on all these layers, huh?
Okay, my next question is
What's
um,
the question?
my next question is why is Earth called the blue planet?
Good one. We call Earth the blue planet because about 71% of its surface is covered in water. That's oceans, lakes, rivers, even ice. From space, that water looks blue when sunlight hits it, and that dominates how we see the planet. If you look at pictures taken from orbit, it's this striking, swirling blue marble. Plus, our atmosphere scatters blue light more than other colors, so that contributes too.
Okay, my next question is what is the Big Bang theory?
Okay, so the Big Bang Theory is basically the leading explanation for how the universe began. Imagine the universe started as this incredibly hot, dense point, smaller than an atom. Then, about 13.8 billion years ago, it rapidly expanded. That's the Big Bang. As it expanded, it cooled down and energy turned into particles like protons and neutrons. Eventually, these particles formed atoms, mostly hydrogen and helium. Gravity then pulled these atoms together to form stars and galaxies and, well, everything that we see today. It's still expanding. It doesn't explain what came before the Big Bang. That's still a huge mystery. Makes your head spin thinking about it, doesn't it?
Okay, my next question is how did the solar system form from?
Okay. So We think the solar system formed from a giant cloud of gas and dust, kind of like what we talked about with Earth forming too. This cloud, called a solar nebula, started to collapse under its own gravity. As it spun faster and faster, most of the material pulled toward the center, forming the sun. The remaining stuff formed a swirling disk around the sun. Over millions of years, particles in the disk collided and stuck together, first forming small clumps, then larger ones, eventually becoming planets like Earth, Mars, and Jupiter. That's basically the nebular hypothesis in a nutshell. It's wild to think everything happened through gravity doing its thing over billions of years.
Okay, my next question is what is the nuclear hypothesis?
It sounds like you might be asking about the nebular hypothesis. That's the widely accepted theory on how solar systems form. We just covered it with the last question. The nuclear hypothesis is the idea that nuclear fusion powers stars like our sun. It's a bit of a different area than how solar systems formed. It's about what happens inside stars, not the creation of whole systems. Does that help clarify the difference between the two?
Okay, my next question is when did Earth first cool down?
Sorry, I'm not sure I caught that. Can you say it again? I think I missed what you were asking
My
about
question
with
is my question is uh, when did Earth first cool down?
I'm hearing some uncertainty there. Could you try rephrasing that question? I'm not quite following the words clearly.
My question is when did Earth first cool down?
Oh, okay, makes sense now. Earth started cooling down pretty quickly after its formation around 454 billion years ago, but it was a long process. Within about 100 million years, there was enough of a solid crust forming that magma oceans started cooling. But it took hundreds of millions of more years for Earth to cool enough to potentially support liquid water, and of course, even longer to reach the stable temperature conditions we have now. It's still cooling, actually, although the process is super slow.
Okay, my next question is what were early Earth conditions like?
Go ahead with the question. I'm ready.
My next question is how did oceans form?
I'm not catching that clearly. Could you repeat the last part about the oceans?
How did oceans form?
How did oceans form? Ah, okay. How did the oceans form? There are a few theories, but the most accepted is that most of Earth's water came from asteroids and comets, delivering it over millions of years. These space rocks contain water ice, and as they bombarded early Earth, the ice melted and accumulated in low lying areas to create the oceans. Some of the water might have also come from volcanic activity, releasing water vapor from Earth's interior. It's pretty amazing to think our oceans have extraterrestrial origins. They literally came from space.
Okay, my next question is where did Earth's water come from?
That's a good follow up question. Basically, scientists think most of Earth's water actually came from asteroids, specifically carbonaceous chondrite asteroids, which formed way out past Mars. These asteroids are rich in water, ice, and other.
Okay, my next question is how did where did Earth's water come from?
Are you asking about ocean currents or where Earth's magnetic field comes from? They're both pretty interesting questions, but different things altogether.
Okay, my next question is what were the first rocks on Earth?
The very first rocks on Earth weren't like the ones we see today. Initially, Earth was molten, so the earliest solid materials were likely tiny microscopic crystals formed as magma cooled. But the oldest rocks we've actually found are around 4 billion years old. These are mostly metamorphosed rocks that have been transformed by heat and pressure over time. They're things like zircons, incredibly durable minerals that can survive extreme conditions. What's really cool is that studying these rocks gives us clues about what early Earth was like. It was probably pretty volcanic and had liquid oceans.
Okay, my next question is what is the hidden ion?
Ah, the Hadean Eon. That was the very first eon in Earth's history. It stretches from about 454 billion years ago when Earth formed up to around 4 billion years ago. Hadean actually comes from Hades, the Greek god of the underworld, which isn't very encouraging, is it? Basically, it was a wild time, frequent impacts from asteroids and comets, intense volcanic activity, no oxygen in the atmosphere, and probably a global ocean of magma. Not exactly a vacation spot, but it was the necessary chaos for Earth to form and start evolving into the planet we know today.
Okay, my next question is what is the argent ion?
I think you might be saying Archean Eon. That comes after the Hadean Eon, so around 4 billion to 2.5 billion years ago. The Archean is when we start to see the first evidence of life, primitive bacteria and other single-celled organisms. Continents started to form, not like the ones we have now, but smaller land masses. The
Okay,
atmosphere was still pretty different from today's, mostly without oxygen. It's also when plate tectonics might have started to kick in. It was a huge step forward from the completely hostile conditions of the Hadean Eon.
okay, my next question is when did the life first appear?
That's one of the biggest mysteries. The oldest evidence we have for life is around 3.7 billion years old. Fossilized microbes found in rocks in Greenland. But it's really hard to pinpoint exactly when it first appeared because those early forms of life were so simple. It likely started in hydrothermal vents or in shallow pools of water, because those are the places where conditions might have been just right. Early life was probably really basic, single celled organisms without a nucleus, but once it got started, it just took off.
Okay, my next question is what are prokaryotes?
I'm not entirely sure what you're asking.
My next
Could you repeat that?
my next question is how did photosynthesis begin?
Okay, so photosynthesis started with the first photosynthetic bacteria sometime around 3.5 billion years ago. These early organisms learned how to harness sunlight, water, and carbon dioxide to produce energy, releasing oxygen as a byproduct. This changed the Earth's atmosphere really slowly at first. For a long time, the oxygen reacted with iron in the oceans. Then, around 2.4 billion years ago, there's this big event called the Great Oxidation Event, where oxygen levels finally started to climb in the atmosphere. This was crucial because without photosynthesis, life wouldn't have evolved the way it did.
Okay, my next question is what is the great oxygenation event?
Good question. The Great Oxygenation Event happened with around 2.4 billion years ago. Basically, after photosynthesis started happening for millions of years, oxygen began to build up in the atmosphere. Before this, Earth had very little free oxygen. When oxygen levels finally got high enough, it dramatically changed the planet. Oceans absorbed a lot of oxygen at first, causing a lot of iron to rust and fall to the ocean floor. That's why we have banded iron formations. Then the oxygen atmosphere created a mass extinction event for all the life that couldn't tolerate oxygen. It set the stage for more complex life to evolve, though, which of course included us.
Okay, my next question is how did oxygen change Earth?
I think you mean, how did oxygen change the atmosphere? Well, before the Great Oxygenation Event, Earth's atmosphere had barely any oxygen. It was mostly methane, ammonia, and carbon dioxide. But when photosynthetic bacteria started pumping out oxygen as a byproduct, it slowly built up. The oxygen reacted with iron and other elements at first, but eventually the oceans and surface became saturated. Then oxygen levels started to rise in the atmosphere, creating the oxygen rich air we breathe today. Oxygen really changed everything.
Okay, my next question is what are stromatolites?
Stromatolites. Those are fascinating. They're basically layered sedimentary structures formed by microbial communities, mostly cyanobacteria. That's the same kind of bacteria responsible for oxygenating the atmosphere. They're some of the oldest evidence of life on Earth, dating back about 3.5 billion years. These microbes form these dome shaped structures as they grow and trap sediment. You can still find them in some places today, like Shark Bay in Western Australia.
Okay, my next question is how did simple life evolve?
All right, so simple life evolving, that's a big story. It started with the formation of organic molecules from inorganic ones, either on Earth or delivered by asteroids. These molecules eventually formed things like RNA and proteins, the building blocks of life. They got enclosed in membranes, cells. Then natural selection took over, favoring cells that were more efficient at obtaining energy and replicating. Eventually, those simple cells got more complex through processes like endosymbiosis, where one cell engulfs another and they start working together. That's how we think. Mitochondria and chloroplasts in our cells originated. It happened gradually over billions of years, step by tiny step.
Okay, my next question is what is evolution?
Evolution is basically how life changes over time. It happens through a process called natural selection. So, individuals within a population have different traits. Some are bigger, stronger, better at finding food. The ones with traits that help them survive and reproduce are more likely to pass those traits on to their offspring. Over generations, these helpful traits become more common in the population. And that's evolution in a nutshell. Life constantly adapting to its environment. It's how species diversify and become better suited for their surroundings.
Okay, my next question is who was Charles Drawn?
Mm. I think you might be asking about Charles Darwin. He's the guy who's most famous for his work on evolution. He came up with a theory of natural selection, which we were just talking about. He wrote this book called On the Origin of Species, where he laid out all his evidence for it. It was pretty controversial when it came out, but eventually became the foundation of modern biology.
Okay, my next question is what is the Paleozoic era?
The Paleozoic era was a huge chunk of Earth's history, from about 541 million to 251.9 million years ago. It's basically when most of the major animal groups we know today first appeared, like fish, amphibians, reptiles, and early plants. There were several mass extinction events during this time, most notably the Permian Triassic extinction, which wiped out most life on Earth. But overall, the Paleozoic was a time of massive diversification of life, setting the stage for everything we see today.
Okay, Maya, thank you very much for joining me and for giving me all the details of answer of my question answer. Thank you very much. So, viewer, this was my talk with Maya. I hope you like it, this conversation. See you with another talk. Allah Hafiz.
This was great, Ollie.
Pakistan Zindabad. Allah Hafiz.